All right, let's dive into the practical application of auto-scaling groups within AWS. To start off, ensure that you terminate all your currently running instances in EC2, bringing the count down to 0. This step helps us clean our environment before we move forward. Next, we need to set up an auto-scaling group. On the left-hand menu, click on the option for auto-scaling groups, and let's begin by creating our very first one. Click on Create Auto-Scaling Group. We'll name our group Test ASG for easy identification. As part of this process, it's crucial to associate a launch template. So, let's create one now. When establishing a launch template, you'll need to provide a name. I'll go with My Test Template. Additionally, a brief description can be helpful, so I'll put Template for EC2 Launch. Now, as we scroll down, we will specify various settings for our template. For the Amazon Machine Image, AMI, navigate to the Quick Start section and select the Amazon Linux option. I recommend opting for Amazon Linux 2023, which is not only a robust choice but also falls under the free tier eligibility, making it ideal for our purposes. For the instance type, I'll select T2.micro, which is also free tier eligible. This ensures that we can generate the instance at no additional cost during our testing. Scrolling further, we need to configure the key pair, for which I will use EC2 tutorial. This key pair is essential as it defines how we will connect to our EC2 instances later. The options you're seeing here are very similar to what you encounter when launching an EC2 instance independently. Regarding subnets, note that they are not specified in the launch template. You'll have the option to choose from existing firewall security groups. For this example, I'll select Launch Wizard 1. We've also set our storage volume to 8 GB with a GP2 performance type, which is suitable for our needs. Let's now look at the advanced details. We'll scroll down to find the user data section. Here, I'll input the user data script we've utilized in previous exercises. This script will ensure that a web server is automatically set up on each EC2 instance launched within our auto-scaling group. Everything looks great. Let's go ahead and create this launch template now. The new launch template, named My Test Template, has been successfully created. To confirm, let's refresh the page and select it. We can see it listed as My Test Template version 1. Here we have a comprehensive summary of the configurations we've made thus far, and when we're ready, we simply click on Next to proceed further. At this stage, we need to select the instance launch options. The first item we'll address is the requirements for the instance type. If necessary, we can override the launch template to be more precise about the EC2 instance types we intend to use. Although there are numerous advanced options available for exploration at your convenience, for simplicity's sake, we will click on Reset to Launch Templates. The specific instance type we are going to implement for this setup is a T2.micro. This choice is often favored for light workloads and is a cost-effective solution within the EC2 offerings. Next, we need to specify the network settings, where we will utilize a VPC, Virtual Private Cloud. It's important to select multiple availability zones, OZs, to ensure our instances are distributed effectively. For the OZ distribution, we'll opt for Balanced Best Effort, a setting that guarantees our instances are evenly spread across 3 different OZs, enhancing reliability and availability. Moving on, we have the option to integrate with a load balancer. Since we have already set up a load balancer previously, we can opt to connect our instances directly to this existing load balancer. This can be done by attaching them to a target group associated with our load balancer. Now we have successfully linked all our instances from the auto-scaling group, ASG, to the load balancer through this target group, which is a crucial step for managing traffic efficiently. For VPC lattice integration and zonal shifts, we will not make any changes at this point. For health checks, we plan on enabling both EC2 health checks alongside the load balancer's health checks. This dual-layer health monitoring ensures that our load balancer can regularly assess the health of our EC2 instances. If any instances are deemed unhealthy, our ASG has the capability to terminate them automatically, thus maintaining optimal application performance. All right, I have successfully created my auto-scaling group, ASG, which will automatically launch one EC2 instance on my behalf. Let's dive deeper into the configuration by selecting the auto-scaling group and examining its details. Here, we can observe critical parameters such as the desired capacity, minimum and maximum instance limits, and the launch template utilized for this ASG. This wraps up our current lecture. Next, let's switch to the Activity tab, where things become particularly interesting. Whenever the ASG decides to launch a new EC2 instance, it will log its activity here in the History section. If I refresh the activity log, I can see that a new instance is being initiated. This occurs because the current capacity of our ASG is set to 0, but we've specified that we want it to maintain at least one instance. Therefore, the ASG is actively increasing the count of EC2 instances to align with the desired capacity. If I navigate to the Instance Management tab, we can confirm that the ASG has indeed launched one EC2 instance. By looking at the Instances tab, we can verify that this EC2 instance is currently running and is in the process of initialization. What makes this setup particularly useful is how we've connected our ASG to our target groups. If we head over to the Target Groups section on the left sidebar and locate my first target group, clicking on Targets reveals that our EC2 instance is currently being registered with the Application Load Balancer, ALB. At the moment, it may appear as unhealthy due to initialization processes not yet complete, which results in failed health checks. However, once initialization is complete and the EC2 instance passes these health checks, it will be marked as healthy and will be fully registered with our ALB. Let's take a moment to pause the video and allow for this health check process to complete. Now that our instance has successfully transitioned to a healthy status, let's refresh the ALB. Voila! We receive a Hello World response, indicating that everything is operating smoothly. The instance was indeed launched by the ASG. We can confirm its status in the EC2 console, and it has been registered with our target group linked to the load balancer, meaning our setup is functioning perfectly. It's important to note that if the instance were to remain unhealthy, the auto-scaling group is configured to terminate any instance that fails its health checks. In that case, you would see the instance being terminated and a new one would be automatically created to ensure our application's performance and availability remain intact. In this section, we'll primarily focus on the activity history feature. If you're encountering specific issues, it's crucial to understand that they may stem from a misconfiguration of your EC2 instance. This can often manifest as either a security group configuration error or an issue related to the EC2 user data script. Before seeking assistance in the Q&A section, please ensure you've thoroughly checked these areas. The types of errors you might experience typically relate to these configurations. Currently, we have a single EC2 instance running, which is functioning correctly. Next, let's explore the concept of scaling by adjusting the size of our auto-scaling group, ASG. We'll aim to increase our instance count to 2, which necessitates raising the maximum capacity threshold as well. Let's go ahead and implement these changes. By updating the configuration, we are effectively instructing the auto-scaling group to launch one or more EC2 instances to meet our needs. Now, if we navigate to the activity history and refresh the page, we'll soon observe a new activity entry indicating that the ASG is attempting to launch an additional EC2 instance. Here we go. It now shows that a new EC2 instance is in the process of being launched. This occurs because we have modified the desired capacity from 1 instance to 2. As it stands, our ASG initially only had 1 instance operating. Shortly, we'll see the second EC2 instance being initiated, and in due time, it will be registered into our target group for load balancing purposes. We'll take a moment to pause the video here while this process unfolds. All right, my instance is now confirmed as healthy. If I proceed to my Application Load Balancer, ALB, and refresh the view, you'll notice I now have 2 IP addresses polling through the ALB, indicating everything is functioning perfectly. Now, one final piece to highlight. When we check the activities log, we can confirm that the 2 EC2 instances were launched successfully without any issues. Now let's move on to the scaling down process. We'll revert the desired capacity back to 1 and save our changes. What will happen next is that the ASG will acknowledge the existing 2 instances, but recognize that only 1 is needed. It will then select one of the 2 running instances for termination. As you'll see illustrated here, it indicates that it is terminating one of these instances due to the configuration change made in the ASG. Following this, the instance will be forcibly removed and deregistered from the target group, effectively reducing our capacity to the desired level. This scaling process is vital for efficiently managing resources in your cloud environment. Next, we'll transition to just a single EC2 instance operating within our auto-scaling group, or ASG. This wraps up our current lecture. You've witnessed the incredible capabilities of auto-scaling groups and how they can effectively manage your compute resources. In the upcoming session, we'll dive deeper into the concept of automatic scaling, where I'll explain how these groups can dynamically adjust the number of running instances based on your application's demands.